Today I'm going to show you how to derive the number pi. First we're going to start with a circle with the radius 1, and we're going to put a triangle in it. It's an equilateral triangle. We'll erase this. And this will equal 1 because of the radius of the circle. And if you split this into a right triangle and divide the triangle into 3 angles from 180, this will equal 60 degrees, and this angle will equal 30 degrees because it's half of 60 degrees. This becomes a 30, 60, and 90 triangle, and after finding the area, the base and height of this triangle, we can find the area of this small part of the triangle, multiply it by 3, and then we will get the area of the whole triangle. We can also do the same thing to find the area of a square inside a circle. This time this would also make a nice isosceles triangle, but it would be a 45, 45, 90 triangle. These two shapes give us these areas, 3 root 3 over 4 and 2, that's the area for the square, and then this one is for the triangle. To actually find the equation for most of the polygons inscribed in circles, we're going to start with the pentagon. This is our pentagon, and we can divide it into 5 equilateral triangles. We can find one of these angles by dividing 360 by 5, which is the number of sides. So that's 360 divided by 5, which equals 72. This equals 72 degrees then. And if you want to make this a right triangle, we would have to divide this in half again, making 36 degrees. If we take this out here, this would be 36 degrees, and to find these, you flip this triangle over and put it on a graph. And that would be like this. This is 36 degrees. And we see that the height of this is going to be sine of 36. And the length of this is going to be cosine 36, which means this is sine 36, and this is cosine 36. To find the area of this small triangle, the base is sine 36 times 2 because that's just half. So the whole thing is 2 times sine 36. And then the height is cosine of 36. So the triangle's area is half base times height, which makes this 1/2 times 2 sine 36 times cosine of 36. And because there are 5 triangles here, we'll multiply it by 5. As you can see, this number is the same as the number of sides in a polygon. So if the polygon is more than 5 sides, it could be 100,000 to 3. We'll just make the number of sides represent n. And then we would do the same thing here, 1/2, because that's the general equation for triangles, times 2 sine of angle. And to find this angle, as you can see, we did 360 divided by the number of sides, so that's 360 divided by n. But we also divided it in half again because of this right triangle that we made. That means we can multiply this by 1/2 and get 180 over n, which equals theta, which is this angle. So it's 2 sine 180 over n times cosine 180 over n. We simplify these two and cancel each other out to give us the general equation, n times sine 180 over n times cosine 180 over n. This eventually gets us to pi because as we increase more and more sides inside the circle, they start to look more and more like circles. For example, we have an octagon, and it looks more like a circle. And if we have like more and more sides, they will get rounder and rounder and rounder. And this is proven by. Okay, so this is deriving pi when the polygon is circumscribed around our circle with a radius of 1. We start with 3 sides, which is a triangle. This is 1, and dividing again, this is 30 degrees, making this a 30, 60, 90 triangle. That's 2, that's root 3. These are 3 equal triangles. And our area turns out to be 3 root 3. We do something similar with our square here. This is radius 1, this is also 1, making this 2. Base times height is the area for a square, that's 4. Again, our pentagon is where our equation comes from. So we draw a pentagon. Our circle and the pentagon. Previously we found that there were 5 equilateral triangles in a pentagon. It's the same case here again. We also found that this equals 72 degrees, and this also equals 36 degrees. So we already know what theta equals. Theta equals 180 over n, like I said previously. To find the area of this triangle here, we have to go opposite over adjacent, which here is sine 36 and cosine of 36. We do this and we get the area here. Opposite over adjacent also happens to be tangent. So our equation here is, for this triangle, is tangent tangent of 36 because it's opposite over adjacent. And then we multiply it by 5 because there are 5 triangles. Again, 5 sides, and for sides, and tangent of theta, and we already know theta. So we get our another equation, which is n tangent of 180 for n. We can prove that this will equal pi because we plug in 10,000 one more time, lots of sides, and that equals 3.141597, close to 26, which is pi. And that is how we have come to pi